A TSBVI outreach tutorial. APH Cranmer Abacus, Part 1, Prime Factorization. Prime Factor, 24. Presented by Susan Osterhaus, a Texas School for the Blind and Visually Impaired Outreach Math Consultant.
Okay, today we're going to look at an abacus, a Cranmer Abacus. This one happens to be from the American Printing House for the Blind. And before you go into a panic and think, she can't possibly have time to be teaching us how to add, subtract, multiply, and divide, to do fractions, to work with decimals on the abacus. Do not panic. I am not doing that for today. For today, I'm going to teach you how to do prime factorization on the abacus. And some people have called this the Osterhaus method of prime factorization. I don't care what you call it. I just hope that you like the method and you and your students use it. And now I'm gonna try to stay away from too high-level mathematics to explain this to you, and I think you'll be able to set the numbers without too much difficulty as well. So do not fear that you have to know everything that there is to know about an abacus before being able to participate and work along with me on this. And that's probably the best thing to do, is to grab your own abacus and let's just work on this together. And I'll try to go slow enough so that you can keep up with me. Okay, we're going to take a number, and that number for right now is going to be 24. I'm going to pick up what I consider a relatively small number. Now, if you look at your abacus, the way the average person would start with an abacus, and I think most abacus books would tell you this, is have all the beads, these on the bottom, pushed this way away from this bar, and all the ones above pushed away from it in an upward direction. Okay, so all the beads are away from the bar that is going down the middle. And way to the far right, we're going to call this first column the ones or the units column. And then the one just directly to the left will be the tens, and the directly to the left of that will be the hundreds. So these are pretty much the way you'd be familiar with, even if you're looking at this in print or if you're looking at it in Braille. So if we're going to put the number 24, the 2 would go into this column, which is the second one from the right. And to do a 2, we're just going to count up. Each one of these beads at the bottom counts 1. So 1, 2. We now have really 20 written because the 2 is in the tens column. And if we want to put 4, we go 1, 2, 3, 4, and we now have 4 in the ones column. So what you see before you in the column just to the left of the first one and the first column, we have 24. So 2 in the tens column, 4 in the ones column. That's how we're going to put our 24 on the abacus. Now, we want to prime factor it, so we have to use prime numbers. In case you've forgotten what a prime number is, this is a number that can be divided by itself and 1. That's it. It's only divisible by itself and 1. And 1 is not included, even though 1 can be divided by itself and 1, since actually that's the same number. It just doesn't get to be a prime number. So the smallest prime number is 2, and that's where we're going to start. So we're going to be very methodical, starting with the smallest prime number, which is 2, is 24 divisible by 2. If the student, and hopefully they do know, 24 is divisible by 2, and they should know this as far as the divisibility rules. Any number that ends in an even number, which in this case 4, it ends in a 4, it will be divisible by 2. So we're going to go all the way over to the left side of the abacus, all the way over there. We're going to place a 2 there. Now we're going to say 2 goes into, as the kids would say, 24 how many times, or 24 is divisible by 2. And if you divide 24 by 2, what is your answer? It will be 12. So you are going to change the 24 to 12 by removing 1 bead from the tens and 2 from the ones, and we now have the number 12. Okay, so far so good. We're going to go back to that prime number 2. We have to basically use that smallest prime number until we cannot use it anymore. And by that, I just mean, is 12 also divisible by 2? Yes, it ends in a 2. It is divisible by 2. So we're going to go back over here to the left side and we're going to put another 2, that's 2 beads, right next to the first 2. So we now have 2 2s in a row. And we would say 2, and I'm going to use the student's expression, goes into 12. How many times? And that would be 6. So we have to change our 12 to 6. In order to do that, we're going to clear the 1 bead in the tens column, clear another bead in the units, and add a 5 bead to the units. So what we now have is our 6, which is left. This is a 5 bead, the one on top, and the one below the bar, but hugging it up, that makes 6. Now we're going to try it again. Will 2 go into 6 evenly? Is 6 divisible by 2? Yes. So we're going to place another 2 to the extreme left, but right next to the other 2 2s we already have there. And 2 goes into 6 how many times? 3. So we're going to change the 6 to 3 by placing 3 beads from the bottom up close to the bar. And now we're going to say, again, we're still trying that too. Is 3 divisible by 2? Finally, we say no. Okay, so we can't divide by 2 anymore. What is the next prime number larger than 2? It's going to be 3. So we're going to go ahead and try 3. Is 3 divisible by 3? Yes, it is. So we are going to place a 3 to the left, right next to our other 2s. We have a now 2, a 2, a 2, and a 3 on the left side of our abacus. No spacing of columns. And we say 3 divided by 3 is 1. And we now have a 1 in our units column. Once we get a 1 there, we are finished. We can stop. We have I'm going to leave that 1 there. We can prime factor 24 into, what do we have down here? 2 times 2 times 2 times 3. Let's check ourselves. 2 times 2 is 4, times another 2 is 8, times 3, sure enough, it's 24. So at this point, the student now has prime factored 24 as 2 times 2 times 2 times 3. They would need to go ahead and get their braille writer out and write that answer down, or they would look at their tax test in case that was somehow related to the tax test, and they would circle the correct answer. But your abacus has kept all that information for you right there. Now let's say that the student was at a little higher level math. They might recognize right off the bat, instead of having to go 2 times 2 times 2 times 3, they could say, hey, there's a shorter way to write 2 times 2 times 2. That would be 2 to the 3rd power times 3. And the fact that you have all those 2's lined up together makes that so much easier to realize. That's why I'm being very, very, very careful to use that 2 repeatedly until you can no longer use it before going to the next prime number. Okay, that is the basic method of prime factorization on the abacus that I wanted to show you today.
This video continues in the TSBVI Outreach Tutorial Series, APH Cranmer Abacus. Look for other videos by Susan Osterhaus on math for the blind and visually impaired. APH is American Printing House for the Blind, a TSBVI Outreach Distance Learning production. Executive producers, William Daugherty, Superintendent. Cyril Miller, Outreach Director. Outreach producers, Susan Osterhaus, Math Consultant. Mike Bicknell, Media Specialist. Texas School for the Blind and Visually Impaired Outreach Programs. 1100 West 45th Street, Austin, Texas 78756, USA. Telephone, 512-454-8631. Website, www.tsbvi.edu. Video copyright TSBVI 2010. All rights reserved.